In this video, you will learn how to solve linear inequalities in one variable. A linear inequality is a relationship very much like linear equations, except that two sides are going to be unequal. They can be of the form ax plus b is less than c, ax plus b is less than or equal to c, ax plus b is greater than c, or ax plus b is greater than or equal to c, where a, b, and c are real numbers and a is not equal to 0. A solution of an inequality is a value that satisfies the given inequality. The solution set of a linear inequality consists of all the solutions of the inequality. There are typically an infinite number of solutions of an inequality. Because we cannot list all the solutions explicitly, we write the solution set in interval or set builder notation. Here are some general inequalities in the way we graph a solution set and write the solution set in interval notation and set builder notation. This first inequality is x is less than a. Solutions of this inequality are all numbers less than a. The graph of the solution set consists of all numbers to the left of a, but not including a. So we shade to the left and put a parenthesis on a. Its interval is written as open parentheses, negative infinity, comma a, close parenthesis. Its set builder notation is written as the set of x such that x is less than a. The next inequality is x is less than or equal to a. Solutions of this inequality are all numbers less than a, but also including a. The graph of the solution set consists of all numbers to the left of a and including a. So we shade to the left and put a bracket on a. Its interval notation is written as open parenthesis, negative infinity, comma a, close bracket. Its set builder notation is written as the set of x such that x is less than or equal to a. The solutions of the inequality x is greater than b are all numbers greater than b. The graph of the solution set consists of all numbers to the right of b, but not including b. So we shade to the right and put a parenthesis on b. Its interval notation is written as open parenthesis, b, comma, infinity, close parenthesis. Its set builder notation is written as the set of x such that x is greater than b. The last inequality is x is greater than or equal to b. Solutions of this inequality are all numbers greater than b and also including b. The graph of the solution set consists of all numbers to the right of b and including b. So we shade to the right and put a bracket on b. Its interval notation is written as open bracket b, comma, infinity, close parenthesis. Its set builder notation is written as the set of x such that x is greater than or equal to b. Properties that we can use to solve inequalities are similar to those we use to solve equations. The basic principle is what we do to one side, we must do to the other. There is, however, an additional consideration when we multiply or divide by a negative number. The addition property of inequality states that if A is less than B, then A plus C is less than B plus C, and A minus C is less than B minus C for some real number C. For example, we know that -3 is less than 4. If we add or subtract the same number from each side of this inequality, the relationship between the numbers is not changed. For instance, let's add 3 to each side of this inequality. We get -3 plus 3 is less than 4 plus 3, or 0 is less than 7. The inequality is preserved when we add a number. Similarly, if we subtract 5 from each side, we get -3 minus 5 is less than 4 minus 5, or -8 is less than -1, which is still a true statement. The multiplication property of inequality states that if A is less than B and C is a positive number, that A times C is less than B times C, and A divided by C is less than B divided by C. If, however, C is a negative number, then we must also reverse the inequality symbol to keep the inequality true. So if A is less than B and C is a negative number, then A times C is greater than B times C, and A divided by C is greater than B divided by C. Consider again, -3 is less than 4. Let's multiply each side by 2. We get -3 times 2 is less than 4 times 2, or -6 is less than 8. The inequality is preserved. We can also divide each side by a positive number and get a true inequality. Now let's multiply each side by -2. We get -3 times -2 on the left and 4 times -2 on the right. Now we're comparing the numbers 6 to -8. To maintain the inequality, we must reverse the inequality. That is, 6 is greater than -8. So when we multiply or divide by a negative number, we must also reverse the inequality symbol.